Hello everyone, my name is Abdullah Keskin and today I'm going to try to answer the questions for the second lab of ee361. Let's start with the first one, the first one was about the RMS values, different RMS values read by oscilloscope and voltmeter. This is the RMS value calculation method. Uh, take the signal, take the square of it, integrate over one period, then normalize and take the square root of it. And if our f of t continuous time signal is sinusoidal, then we can directly calculate its RMS value by this ratio, taking the peak value and dividing by square root of 2. For our equipment, they are digital materials, so they use discrete time signals. The method presented here, we have to take samples, taking square of them, summing them, and then normalizing. And after the normalization, we have to take square root of the total sum. This is what probably our voltmeter does, and as a result of this, our voltmeter reads the correct value of FRMS, our signal, RMS value of signal. But what if our signal is not sinusoidal? Applying this method will produce some errors in our measurements, and probably in our oscilloscope that's the case. Maybe voltmeter reads this one, I don't know, but one of them used this method, taking regarding the signal as a sinusoidal, pure sinusoidal, and taking its peak value and dividing it by 2. However, if you look at the experiment, especially when the voltage becomes higher, our current changes and the linear relation linear relation was lost. The signal wasn't a purely sinusoidal. Strange shape was obtained. So this is the reason why different RMS values. So let's go with the second question, and it was about the core losses and why do we use BH curve. Core losses composed of eddy current losses and hysteresis losses. But in our transformer we are using laminated electrical steel and low frequency. The laminated electrical steel reduces the effect of eddy current losses, and also our operational frequency is relatively low, and as a result of both these conditions we have a hysteresis losses which are more dominant than the eddy current losses. Because of this, only calculating the hysteresis losses will be enough to consider the core losses in taking the core losses into account. And this is the losses for hysteresis loop. This is the supplied energy for our core, and for one sinusoidal cycle. And if you sum them, these two you take hysteresis losses for one period. And third question was about different measurements for open circuit test, but one measurement for short circuit. For this one, please refer these figures shown here. In our open circuit test, we are opening the second branch and we are trying to characterize and find the parameters of parallel branch. This parallel branch represents the losses related to core or iron. So to find this one, we are using open circuit model. And if you look at this one, a similar one can be found also in our lab manual. We have different hysteresis loops as seen here. Also, you can observe this one in the lab video. These correspond to different voltage levels, which means if we have a different voltage level in our primary, we have a different hysteresis loop and hysteresis loop losses. So the parallel branch parameters are directly related with the hysteresis losses, and they will also change. For the one voltage level, we have different hysteresis losses, different parameters. For the other voltage level, we have totally different parallel branch levels. So we have to take different measurements. But in our short circuit test, what we are trying to find, what parameters we are trying to find is that R equivalent and X equivalent, and these are the copper losses, especially this one. To find copper losses, we just applying one voltage or level or one rated current level is enough, because this is just a copper loss and it doesn't depend on the applied voltage. it's valid for applied any voltage, especially, but in this case our frequency is constant. Please keep in mind that. And especially this one refers to the leakage inductance. This is also independent from the applied voltage in our case, so taking a man measurement for short circuit model is enough to characterize the copper losses of our and leakage fluxes, taking the leakage fluxes and copper losses into account. So this was the last question. Thank you for listening. See you next time.